Welcome to Wunyo Tech. I'm Dave. I build pretty stuff. I build beautiful machines. That's what I try to do. I have to look at the fucker all day long. I want it to be beautiful. So that's what I've been doing for a little while. And with this current build, I added a performance aspect to it. So we've done some overclocking and tuning and all of that stuff. I try to put as much effort into that. Actually, I put more effort into that than I did to the building part. But when it gets to the building part, that's when I have fun. I like creating stuff. I like tubing. I like deburring the tubes. I mean, I just love all that shit. So I love custom cooling, and I try to build like really unique things, interesting things, and hopefully, as this, you'll see me develop into being better and better at that. So anyway, first of all, let me just go ahead and show you this build, and then I'll talk a little bit about it. I guess I'll talk over this. So this is how it worked out. On the right, you see Radical custom built reservoir by Mario, Radical Custom. That right there, that is all fittings right there. So you're tightening in one end while it's loosening the other. That was very difficult. That wasn't hard to. Nickel plated brass. Now here we see the 14 millimeter fittings. When I said fittings before, I meant just G and a quarter. So there's the Aqua computer flow meter, dual D5 pumps. That long bend across the bottom was quite easy. You have the bottom radiator to look at to level you know. Nice plug fitting there. I forget where I bought this. Beauty. Those have to bend. Those are knuckle joints right there that you're seeing on that side rad. They have to bend down. Otherwise, they won't fit in that recessing cage that mounts the side rad. They'll bang against the top rad. And there's bottom stuff, mostly grands and fittings. Custom cable mod cables, so a couple custom things in this case. Cable mod for the NZXT, what is that? C1500, I don't know. New ATX 3.1 1500 that they put out. Good power supply, RAM water block, Iceman RAM water block. Delidded 14900K direct eye cooled thermal grizzly block. So that's the build, and I want to talk a little bit about it. I want to talk about how it came to be and some mistakes that I made, because I made quite a few of them, quite a few mistakes. But I guess what I kind of want to get to is there are some lessons that come with doing this and making these mistakes, and I make them every build. But once you have a theme, what I discovered, once you have a theme, like the thing's starting to come together, you don't quite know how it's going to work out. In my case, it kind of looked a little bit robotic, looked like it was pumping. Those 14 millimeter fittings from Granson, they have a little knob on them to make it so that you can turn it. And when they're not aligned, it really looks like it's pumping, like everything is pumping. It looks like a pump. And then it kind of has this effect of like spider walking a little bit. It kind of looks like it's walking as it's pumping. It's sort of like steampunk kind of, Howl's Moving Castle kind of shit, except a more chrome sort of industrial kind of coldness there. I really like the way it turned out, but it's the theme just kind of developed. It was I just looked at my problems, I thought about how I was going to solve them, and then the overall aesthetic sort of emerged of it. Now, once you're at that point, don't sweat small stuff. So that's the lesson. Like, once you find that theme, don't worry about these fans. I mean, I don't really like the way these, don't worry about all that stuff. It's all going to come together because the idea is guiding you. You just have to avoid the big mistakes. There are recoverable ones. Like, for example, I had one point where I went into the BIOS and it was idling at 90C. 90C in the BIOS is a problem because the BIOS doesn't pull anything. But that's why when you start up your rig, after doing any big change, or if you're building it fresh, Or if you buy a pre-built, the first thing you do is you're mashing F2. You got to get into that BIOS and see where it's idling in the BIOS, because the BIOS pulls nothing. If you go straight into Windows, maybe start playing a game, you could brick your shit dead. So how you know what I will share in subsequent videos, because I took some during this build of what it was that caused me to be 90 Celsius in the BIOS. And it was a real simple thing. It's just dumbass thing that I forgot. But that dumbass mistake could have been disastrous. So, but missing an in and out that I should have built into the loop so that the loop wasn't circulating. I mean, that could be a huge mistake, or it could be a nothing burger. And the reason it's a nothing burger, and it's because and part of the reason I work so fast and I'm prone to making those types of mistakes, is because I know I'm going to be mashing F2. I'm not going to be booting straight into Windows, and I'll find the issue. So make the mistakes that could otherwise be big little by avoiding the big mistake, which is you got to mash F2, get in that BIOS. Okay, so I hammer that home. Future plans, videos. It's going to be a lot of building stuff, but not necessarily a gaming rig like this. I'm going to be building a NAS system, Plex server, and an AI machine. My friend and I have plans for that. You can expect some of that upcoming. And I'm just trying to get this channel up and running. And really the whole point of the channel is to share the joy of tech and, just sort of take away some of the bitterness that you see in this space and share what makes us happy. And if it's our hobby, it makes us happy, and just talk about our hobby and have fun. That's the point of Wunyo. That's the point of Wunyo Tech. Fill ports 2, 4, 6 graphics card, 6 that we're using. Okay. And radiators, 2 or 6, so that's a total of 12, because 2 in each rad. Okay, 2 in a reservoir, that's 14. We got a second reservoir, that's 16. We got a pump, that's 18. We got a second pump, that's 20. We got a flow meter, that's 22. So now, but the flow meter is probably, we could call that 20, because that's going to be absolutely in line, right, with something else. I mean, yes, it is 22, but it's not something we probably don't have to worry about making a bend with. So anyway, that's a lot. So how do we get around this? Well, first of all, the first thing you got to do is put the fans in, because otherwise you don't know what space you're working with. Now, hopefully, when you plan this, you planned it with great fittings. These are Grandson fittings, and I can do that. And because I can do that, just that, this side radiator assembly will fit into this bracket. Okay, don't want to do it with one hand. But if they're up here, it's not going to fit. It's going to smash into this top rad. So that's why I have those two coming in the top, because it can only be one or the other and not out the bottom, because they're actually going to look quite pretty, even though you will only see these extension fittings. You will not see these Grandson ball fittings. Yeah. So anyway, hopefully I can get these videos affiliate linked in the future. So 22 in and outs, right? Whew, how are we going to do all that? Quickly, cable management. You're not going to see this cable here on the side. It's going to be covered up. When it goes into the assembly, you'll see. But over here, you got to keep them together. That's twisty tie. That's actually a paper clip. It's tied around. If you want, you can stick with that. Just use a handy set of dikes. Cut those ends off. But you make these decisions ahead of time, right? So if you want to build a custom loop that is with aesthetics in mind, understand that you will notice that. All right? You're working on a finer scale. And you can indeed see it. the camera should be able to pick up that the right side, facing it the right side, the fill port side's got to come up a little bit. By the way, this is a custom reservoir by Radicult Custom. He did a great fucking job with this thing. It's beautiful, wrapped aluminum, exactly what I wanted. I got 4 fill ports, one on either side at different levels. So, any event, we actually have our fitting here. And as I was doing this fitting, this bends back so it can fit in there. I'm holding my phone, so I can't really do it right now. But when I did that, I noticed, I really noticed how unlevel that was. Now, we got another issue here. They don't quite line up. Now, that doesn't bother me so much. I'm going to figure out ways to mask that with some crossways, with some angles in the loop. But what does bother me is that this is also out of level, this top pump. Now, I think that in both cases it's the mounting, and I think over here with the custom job, which I have played with, I've been using this reservoir and it works fantastically, but I think I could use a different screw for this mounting. This is not a recommended mounting. As well as the bottom pump. I wanted 2 pumps in this build. I got used to having 2 pumps on my test bench with 1 reservoir, and that's the way I like it. That's the way I sort of tune this thing. I left it, I could maybe tighten it some more, but it's going to be in an entirely different environment, but I wanted to have my 2 pumps. So we got this straight fitting, and then I noticed how out of level that was, and then this one came into focus too. I think it's the back mounting, but the frame looks a little bit out of level. So I got to figure out what's going on there. And since I didn't use it here, I have a different frame that I could use to improve that. So anyway, I guess the lesson of the video is like every little millimeter off you are is a big deal. You're going to notice it in the further aesthetics of your build. You're going to notice it in your long bends, which I have a lot of those to make. And you're never going to stop seeing it, but other people will notice it too. You just won't say anything. So if they're thinking about aesthetics like you are, if you are, this is a channel for you. And there's some other little confusing things about this build. Anyway, this project was both for performance and aesthetics. I did tune this guy and optimize this guy before I put it in the case. It's running 7800 RAM. The timings are tight. The secondary timings have been tuned and are looking good. It runs stable. The CPU has been, first of all, it's been, the ILM is off, and it's been treated with liquid metal, and it's a thermal grizzly direct eye block. But it's also been had core locks to prevent against degradation, sort of monitoring vCore, adjusting load lines in order to get a good, what would you say, a good, what is the word I'm looking for? Discrepancy is not the word, but that's the only one I can think of. Delta. A good delta between vCore at idle and vCore under load when it throttles down. You don't want it idling too high, and you don't want it getting too low. I've got a nice delta. I think it's really around 1.4. Now it might be getting a bit hot at idle. 1.4, 1.41. I think it usually stays around 394 last time I checked, so just a fart skin under 4. but it throttles down to about like 3.7, which just for me is a beautiful delta. GPU is the easy part. Just basic undervolt. Low, getting a power limit up, but with an undervolt kind of thing. GPU tuning is pretty easy, unless I'm just doing it really, really badly. But I expect this thing to perform well. Tested stable. Carhu RAM test passed 24 hours on each side. So with each DIMM slot in either stick of RAM, each DIMM slot. So this thing is humming. It's performing very well on the test bench, and so we've got the performance aspect, and now we're just thinking about aesthetics. And you do it as carefully as you do anything, as you do the performance aspect when you tune and optimize. So, like I said, when I got to this build, I noticed that the whole thing was off, and that's the way with little things, they reverberate. So we got to figure out. Fortunately, we have a backup stand that we can use for this one if it's the stand. And then it might just be tightening, and it might just be the rear mount. So we'll figure that out. I'm certain this one is the screws because it's an irregular mounting. It's not meant to be mounted this way. So anyway, we've got some issues to figure out, but yeah, it's just a comprehensive build and a really cool project. No RGB, and I think it's going to look fantastic. Subsequent videos will be of higher quality. I promise. Thanks. Oh, I just wanted to show the fill port. I forgot to talk about it. So that's this guy here, right here. You kind of have to be careful how you move it. Not that it's going to leak, it's just that if you keep on twisting it and don't pay attention, it could end up loosening on you. So right now it's just a fitting that's turning. But anyway, that's a fill port. And using these fittings, it kind of bends out a little bit. There you go. Sorry, it's tough to do this with one hand. So anyway, that's how we'll probably strap a hose right here with a plug fitting and then just drain it. So you want to make your fill port as close to the bottom of the loop as you can. I just really wanted this bend. I didn't want something coming into the graphics card at the same in the same alignment with something coming out. So I had to have it over here. I don't know if that's a have to. Technically, I just think aesthetically it's a much better. And the fill port with these Granson fittings, GDSK I believe, turns very easily. So it's nice. But yeah, just wanted to show you that. Okay, here goes nothing. That's cool. All right. Let's see if we have any, if this start button is working. It is. It is cycling. We're still waiting because I have fast boot shut off, so. Oh boy. I feel like something should be happening. Okay, we're good. Alright, we're in the BIOS. We booted. And she looks beautiful. Got to get rid of that RGB. I don't want that. But this is the Aqua Computer flow sensor without the octo or quadro. I'm just using a fan controller, Arctic fan controller. Gives you a decent bit of information. I have to play around with that. Got to figure out how to get rid of that fucking RGB. And I've still got a bit of RGB coming from the RAM, even though I've water blocked it. So yeah, that sucks. So I got to figure out if there's a way to turn that off. But she looks beautiful. And we're in the BIOS. Now, the important test. This is what matters above all. Oh no. Oh no. 89C at idle. Well, we have to shut down. And we got to start over. Wow. Wow. So there she is. She's a beauty. Now let me show you what happened that last time when I got 89 degrees idle in the BIOS. It was this. It was this missing linkage right here in the loop. The top radiator was receiving from the output of the CPU block up into this top radiator, and then the loop was dying right there. It wasn't flowing back into the reservoir. I just forgot. So I had to make this connection right here. As soon as I did and I started filling the loop up, I noticed that the water wasn't so still. It was moving quite rapidly. And I noticed that I was filling and filling and filling. I couldn't believe how much more water it took to fill this loop. Just power cycling for a long time. And plus the way this angle is, filling this up is quite difficult. It's getting like air bubbles and I would get some spillage. I hooked a hose up to it so that the water didn't fall anywhere inside the case. But anyway, just that one fitting to complete the loop. That was it. That was the entire difference. If you look here, I'm at hardware monitor. I'll go ahead and go up here so you can see some of the temps I'm getting now. Where am I? Good temperature read. Okay, well, that'll work. It's by core. You see, I'm not hitting 30 on any of these cores right now. CPU package at 36, right? At idle, obviously. And that was it. That was the entire difference between 89 degrees idling in the BIOS and what it is now, comfortably humming away around 35 package. So let this be a lesson to you. When you finish your build, it doesn't matter if it's been built, like in my case, I had it on the test bench already. It wasn't quite new, so it was ready to just press power and go right into Windows. But if you do anything building wise, then when you start up your rig, you're immediately mashing F2. You see, if I had 89 degrees idling in my CPU, and instead of going into BIOS, I immediately loaded into Windows, I could have bricked this whole thing. Look at all this work. I could have bricked it. I could have killed my CPU right then and there. Just loading Windows, you'll hear the fans ramp up, any PC, whatever it is. As soon as you go from BIOS into Windows, you'll hear the fans ramp up. You get an initial voltage spike whenever you load Windows. And that spike, if you're idling in the BIOS, which pulls nothing at 89C, that spike could kill your CPU. Dead. And then I'd have to start all of this over, if I even could. So let that be a lesson to you. Anyway, and also let this be a lesson to you. This one bend right here, going back into the reservoir, finishing the loop, is what took me from idling at 89 degrees in the BIOS to a nice, comfortable 30 or something. Isn't that incredible? 60-degree difference just from completing the loop. I just forgot to complete the loop. So that's it. Sometimes you make bonehead mistakes, but almost anything is fixable. You want to eliminate the unfixable mistakes. What would be unfixable? Well, booting straight into Windows when you would have been idling in the BIOS alone at 89C. That could have been an unfixable mistake. So you want to eliminate those. But this right here, quite fixable. Anyway, there she is, completed. She's a beaut. Just wanted to show you this really quick. So I'm running OCCT CPU plus RAM test. Now, when I was tuning this rig, I would just run OCCT 3D, that's the GPU test, and then I would run Karhu with it. So I actually haven't run this particular test, CPU, and it's kind of cool that you can do it, that OCCT has it. I have a paid version of OCCT, supporter. And I think it's just well worth it. It's so cool that I can run this test both at once, CPU and RAM. Now, if I look at my RAM temps, they are climbing. And as you can see, VDDQ and VDD, I have tuned in the BIOS when I was tuning this, I was at like 1.48. That's about where they are now. That's the setting that I left it on in the BIOS, so these sticks of RAM, and that's what I got stable. But on the open air test bench, I was at about 55 right now. 55, that's no water block. Now I've got a water block on there, and you could see we haven't even kissed 35 yet. I mean, it's a 15-degree difference, water blocking RAM. Very, very worth it if you want to FAFO and tune things. Now, I wanted to show you this too. This is how you know you've got a high-functioning system. You see this? Let me go ahead and highlight it. The V-core. Now, if you look at the V-core, I'm throttling down to 1.35. My average is, say 1.327, but we're staying at 1.34 to 1.36 when it throttles down, and it's at 1.394 idle. So, you know, we're talking less than half a volt of a delta between the idle and when it throttles down. That's where you want to be. That's how you know that you've tuned properly. And so if you look up here, it'll show you where my core locks are. Remember all that shit about degradation? Intel degradation? This test is about to end, so I just set it for 5 minutes. Yeah, but you remember all that shit about Intel degradation? See, it just ended, so you're going to see it down. But it was steady 5.8 on the P cores, 4.3 on the E cores. That was my core lock. With that core lock, initially, my V core was quite high. A little bit too high for comfort. Right? So now we go to I'll check my V core again. And it's 1.412. Not bad. Not bad. Maybe a little high, but it's fine. But 1.412, and it should get down to 1.394 or something. That's where I was in the BIOS. The BIOS is far less granular than hardware monitor, and I was idling at 1.394 in the BIOS. So anyway, 1.3, you know, right around 1.4, 1.41, but then throttling down to anywhere between 135 to 138. So that's a good delta, and you achieve that with load line calibration and with offsets. So it's one of those things that you play with. But anyway, this is how you know you have a nice stable system. That is the essence of CPU tuning. You're really monitoring, you're locking in on that V-core. And you want a good delta between the idle temps, and some would say 1.41, the 1.2 is a little bit hot, but a CPU can handle it. But that's the prevention against degradation. Okay, this guy will not degrade because we're idling at a comfortable temperature and we're not throttling down too low. We're not getting too high or too low. And of course, this has absolutely no effect on performance. Right now, mine's at P-core's locked at 5.8 gigahertz. There's, you're not going to gain anything from trying to push it to 6. And 5.9 was a bit too high for comfort. So I just wanted to show you that so that you can see what the essence of a well-tuned CPU is, or what that really means. The package power on this, now this is a large test, so it's not the most stressful test, but you really shouldn't be kissing 70C package on tests like that. And I was down at around 60. Of course, this is, you can see the effort that went into cooling. I'm saying with that effort, you really shouldn't get around 70 on any large CPU test. So, and your vCore delta should be a good one. So that's the essence of like how you tune. The best way to verify that is by running a stress test and monitoring your vCore. Same way you tuned it. You tuned it by monitoring your vCore. So I just wanted to show you that. Okay, I hope you enjoyed that collection of phone videos. I have condensed these 5 tips into this little list here, and I hope that you have some more confidence. Let me turn myself down a bit. I hope you have some more confidence approaching your build by observing my mistakes. So the first tip is, and you saw all of these in the videos, use great fittings, okay? Use great fittings. Really invest wisely in your fittings. You saw on that side rad, that little shoulder fitting that I had by Granzin enabled me to fit that assembly into the case. Otherwise, it would have banged against the top radiator. You put a lot of thought by reading the case manual so you know how big the radiators are that you can fit inside that case. Put that same amount of thought into your fittings. Get a lot of 45s. You're going to need 45s. And get some 45s that, excuse me, I meant 90s. But get some 90s that can be turned into 45s. The ones that are flexible with shoulder joints. I've got a lot of those in that build. So I would say every angled fitting ought to be able to do a 90. And if it can do a 90, some of them can have the flexibility with those little shoulder fittings that they can do 45s. But you're going to need some 90s, and all of those angled fittings should be able to give you a 90. And then if you need to adjust them, you can make it do 45. Don't go buy 45s. There's no way that you will be able to plan a loop far enough out ahead that you're going to know when you need a 45. And also, if they're flexible angled fittings, then you can adjust the whole assembly. Like you might build a connection between, between a couple ports that has like 2 angles in it, and that connection, you can just sort of move that entire connection until you can level and plumb it. You don't want to do that when there's water flowing through, but as you're building it, you can kind of finagle things and put them where you want them to make sure they're level and plumb. You can do that with some fittings that are shouldered and can go from 45 to 90. So invest in great fittings. Cable management, you saw that with the side rad when I took that paper clip and wrapped it around those little cables for the pump. Just think ahead about that type of stuff. Just think ahead. Think what you're going to need. Think what's going to be in your way. When the fans are in, the rads are in, graphics cards installed, but you haven't built the loop yet, install all the cables from the motherboard, from the case I/O. Get all of those plugged into the motherboard. Get it ready, because if you're a big guy like me and you got big hands, you don't want to be fucking around under these hard tubes, So get everything plugged in, get everything ready. Think ahead about your cable management, and treat everything in the loop. Treat it like you're going to see it every day. Treat it like everybody else is going to see it every day, even though they won't. That includes what's going on in the back of the case. Treat everything with a circumspect eye, right? Have attention to detail and think ahead. Level and plumb everything. You didn't see this in the video. You saw a little level. It was a 6-inch level. I have a 3-inch level. I could not get, even though I replaced the screws and made sure it was a secure back mounting, the reservoir, I couldn't get it to stay level when it had water in it. The weight of the water brought it down on one end. So I cut myself a piece of tubing, put some rubber on both ends, made it look nice. And that piece of tubing is holding that reservoir level. And when I want to make little changes, like I want to get access to the back of the case, I have to move it around. It doesn't come out of there. It stays right there, even though it's not attached, it's not glued down, there's nothing holding it. It's just a piece of tubing. But my 6-inch level wasn't big enough to make sure that it was level and plumb, and you want to make sure everything's level and plumb. So get yourself a 3-inch level, which brings me to, it's a nice segue to another video you're going to see on this channel, which is my shop. I want to show you my workshop, and I want to show you all the stuff that you're going to need to approach a hardline liquid cooled job like this. So we're going to have a workshop video. Now I've hammered this one home. Number 4, always F2, or whatever your thing is, F9, delete into the BIOS, always get into the BIOS first. You saw why in these videos. You're trying to turn a big problem into a small problem. Okay, the problem that was small, that could have been big, was idling at 90 degrees in the BIOS. You know something's desperately fucked up at that point. But it turned out to be a small thing, small correction that needed to be made. The reason that it was small is because I F2'd into the BIOS, because I'm reading the temperature into the BIOS. Now this doesn't just go for building. This goes for buying a pre-built. You buy a pre-built, get it from Micro Center or something, who knows what could happen, okay? You might have had a good builder, you might have had a shit one. A lot of these pre-built companies, a lot of these guys are fucking hacks. Not all of them, not all of them. We're gonna go deep into the pre-builts, but a lot of them are hacks. A lot of them are not careful, and there might not be enough contact pressure on the CPU block. They might not have applied enough paste. You could have an overheating disaster waiting for you and have to, waste a lot of time with RMAing. You get that pre-built home, it's built so that you can boot straight into Windows. You're not doing that. You're F2, F9, delete into the BIOS right off the bat. Getting into the BIOS, looking at the idle temps in the BIOS. Then you'll know whether you can, that's my cat Elroy, then you'll know whether you can boot into Windows. So I think I've hammered that one home. And you'll make mistakes. Don't panic. Ugh. He hates that. He wants my attention. Just a second, Elroy. He wants to be fed. You're going to make mistakes. So let me show you one that I made. So I had things set up on a horizontal test bench. I had just water blocked a graphics card. So I do everything right? Like I think I've got the test bench set up. Reservoir soft tube, everything soft tube, just for testing, just for messing about on the horizontal test bench. Put the graphics card in there where it's supposed to be. I'm running the loop off an external power supply, no current going into the board, like you're supposed to do, right? But I got a leak, yeah? And I didn't notice it. My water block was covering up where the puddle was. Like I said, it was set up horizontally. There was a puddle. So a couple things saved me. Number 1, I had a good motherboard with some sort of shutdown circuitry in it that disabled the PCIe slot, and that's why when I booted, I got no display. And then when I looked more closely at it, that's when I saw the puddle. So it shut it down before I could get a short on the board. So that was nice. That saved me. And I use good water. Good water is one of those things. I was using deionized water. That's one of those things that can turn a big, big problem into a small one. So that helped me survive this. Because I had turned power, I had made all my connections, and current was going into the board while it was leaking. And there was a puddle right there over the PCIe slot. So that was bad. I really, really fucked up. That was bad. You should not be making mistakes like that. But I'm letting you know that a couple things saved me. Number one, I bought a good board, obviously. And number two, I was using deionized water. And I think that's what saved me. So I took everything apart. I didn't panic. I was hoping that the gods were on my side. Turns out they were. Didn't know that, but still didn't panic. Took the graphics card apart, the water block apart, took my electric duster, sprayed off every droplet of water, sprayed, got the duster out, put it on the board, blew off every single droplet of water I saw, made sure that the board was bone dry, graphics card was bone dry, put it back together, it worked. I lost a BIOS setting. That was it. I lost a bit of work I'd done on that profile. That's it. The gods were on my side. So you will make mistakes. Now, if I can make that mistake, then don't worry. You can afford to make some little ones. Learn from that. Make sure you look closely when you have everything, when you're testing your loop. Don't miss. You might have a little leak that you didn't see. So look very, very closely when you're testing your loop before you put current into the board. That's one of those cases where you'd rather be lucky than good, right? But you will make mistakes. Hopefully none as thoughtless as that, but you will make mistakes. Do not panic. The other thing I was able to do to recover from that was to not panic. I immediately shut down, dusted everything, got everything bone dry, tried again, and the gods were on my side, and I'd used good water and had a good board. So I survived. So you can even make terrible mistakes, and you might still be okay. And the other one I put in as kind of a bonus. This build, I didn't know what it was going to look like. The pump-like quality, the industrial, sleek aesthetic of it, I didn't quite know how it was going to come together. And now I see it's got this sort of T1000 vibe about it. Once your theme emerges, don't second guess yourself. You've done everything right up to this point. It's coming together. It's looking nice. And the idea is guiding you. You're really this is artistic. This is an artistic enterprise, right? And so let the idea guide you. So at one point I thought, I'm not sure I really like the look of these fans. And don't worry about all that. It'll all come together as long as the idea is cementing itself, and what used to be just an idea is becoming a material reality, and you're feeling that process, and the whole thing's coming together, and it's starting to look beautiful. Don't worry. The idea will take over. Don't sweat the small stuff. Let the little stuff be little. That's sort of the sixth guideline here. So anyway, I hope you enjoyed this video, this walkthrough of a big, complicated loop. I hope that you learned from my mistakes. I hope that if you've been on the fence about playing around with hard tubing and water cooling, that this gives you a little bit of confidence, that you might be able to get away with a few mistakes here as long as you're careful on some other things and buy good components and good fittings and use good water and do everything in your power to turn potentially big mistakes into small ones. You should be able to build with confidence and, most of all, have fun. So this has been Wunyo Tech. I'm Dave. I'll see you in the next one.